Hi, welcome to this video where we're going to look at representing numbers as a product of prime numbers. Now, I've already done a video on prime numbers and showing whether a number's prime or composite using physical materials and arrays. But today we're going to look at factor trees and representing numbers using a factor tree and then as a product of primes. Now, often we overlook the absolute power of prime numbers to mathematics, especially in terms of multiplication, and with that comes any of the concepts where we're using multiplication and where we're required to do things like simplify, find common factors, find common denominators, and so on. So let's have a look at how we can extend students' understanding of prime numbers to really build their foundation of multiplication and where they use it in mathematics. Now, factor trees are something that I find students generally have some solid success with. Even if they don't know their times tables, most of them can represent a number like 24 in a factor tree, because they are very good, or tend to be very good, at halving and doubling. So they can see 24 as 2 times 12, 2 times 6, and then 2 times 3. They've broken 24 down into prime numbers multiplicatively. So 24 is equal to 2 times 2 times 2 times 3. This is 24 represented as a product of prime numbers. It's 24 being shown as primes being multiplied together. And that happens for every number. We can represent every number as a product of primes. They are the multiplicative building blocks of our number system. 36, they could have worked quicker by thinking of 4 times 9 rather than their halving, and 3 times 3. So 36 can be written as a product of primes, 2 times 2 times 3 times 3. Now let's have a look at how we can use that in a number of different ways. First of all, let's use it to help us find all the factors of 24. Now, most often, if we ask students to list the factors, we're requiring them to remember their multiplication tables. But they can use this product of primes to come up with a list of factors as well. And that means looking at all the different combinations. Now, 24, we know 1 is a factor of every number. And it's not a prime number, so that's why it's not appearing here. So we write 1 first. But then we look at all the possible combinations of the prime factors. We can have 2 by itself. We can have 3 by itself. Let's look at combinations of 2 numbers. 2 and 2. 2 by 2 is 4. That's going to be a factor. 2 by 3 is going to be a factor. 6. Let's look at combinations of 3 numbers now. 2 times 2 times 2 is 8. It's a factor. And 2 times 2 times 3 is 12. And we've now exhausted our combination of 3 numbers. We're up to our combination of 4 numbers, which is all we have left, and that's our 24. So that's helped us find all our combinations, all our factors of 24. Even if you have students who are really good at remembering their times tables, it's worth them seeing how this product of primes can be used to find all the factors, especially for when they're getting to much larger numbers. But it also shows them the building blocks of numbers using primes. So that's using it to find the factors. Check out the next video, which helps us to use products of primes and factor trees to find highest common factor and the lowest common multiple. I hope you've enjoyed this video. Hit subscribe so you can find those other videos where we use products of primes, and head over to learningu.com.au to find further teaching resources.